Question number 18. To address the susceptibility of materials used in components of high performance machinery, such as aircraft engines, to creep, deformation that is induced by persistent mechanical stress and that often occurs at elevated temperatures. Materials researchers have developed silicon carbide SiC fibers for producing aerospace composites. Testing the thermomechanical properties of several commercially available SiC fibers, Ramakrishna T. Bhatt et al. Found that in comparison with two polymer-derived SiC fibers, a nitrogen-treated SiC fiber exhibited a lower minimum creep rate, a measure of the rate at which a stress-exposed material deforms at a constant temperature and uniaxial load. The finding suggests that blank. Which choice most logically completes the text? Is it A? Unlike the two polymer-derived SiC fibers, the nitrogen-treated SiC fiber can substantially inhibit creep provided that temperatures and loads are consistent. B. The two polymer-derived SiC fibers likely hold similar potential for reducing the creep resistance of materials exposed to stress and elevated temperatures, thus prolonging the lifespan of aerospace machinery. C. Composites based on the two polymer-derived SiC fibers have chemical properties that may improve the mechanical and thermal stability of aerospace equipment to a greater extent than do composites based on the nitrogen-treated SiC fiber. Or D. Aerospace composites containing the nitrogen-treated SiC fiber may have the ability to withstand mechanical stress for a longer period of time than can aerospace composites containing either of the two polymer-derived SiC fibers. So what we can see is that they are addressing the susceptibility of materials used in components of high-performance machinery. So in aircraft engines, we need to keep them quite strong and we have to reduce the creep, that is deformation induced by persistent mechanical stress. And when does that happen? So that often occurs at elevated temperatures. So when it's quite hot, there can be a deformation which we are calling as the creep. And then the researchers, they have developed silicon carbide fibers for producing aerospace composites, and obviously testing is required. And so several commercially available SiC fibers have been tested, and Ramakrishna T et al. What he has found? He has found that two polymer-derived SiC fibers are there, but when a nitrogen-treated SiC fiber, what they checked is that exhibited a lower minimum creep rate, a measure of the rate at which stress-exposed material deforms at constant temperature. So the creep rate is lower for this one, for the one which has been nitrogen-treated. So which one should we select to complete the text logically? So at first glance, we might think that the answer is A, but A is actually not correct. A is incorrect because it overstates the implications of the study's findings, which have to do with the rate of the material's deformation under stress, not the absolute degree of deformation. So the text states that Bhatt et al. Observed that nitrogen-treated SiC fiber had a lower minimum creep rate than two polymer-derived SiC fibers did, meaning only that it deformed more slowly over time under constant stress, not that it underwent less deformation overall. So it will also undergo deformation, but only a little bit more slowly. So selecting A is therefore not correct. B is also incorrect because the text doesn't establish any similarity between the two polymer-derived SiC fibers, other than that both had a higher creep rate than the nitrogen-treated SiC fiber did. Bhatt et al. Study. Moreover, reducing a material's resistance to creep would mean that the material becomes more susceptible to deformation with exposure to stress and elevated temperatures, which would be expected to shorten rather than prolong the lifespan of machinery made with that material. So it will not prolong the life, it will reduce. So this cannot be selected. And C is also incorrect because the text suggests that the stability of aerospace equipment may be better improved by composites containing nitrogen-treated SiC fiber than by composites containing the two polymer-derived SiC fibers, not the other way around. The text indicates that Bhatt et al. Observed that the nitrogen-treated SiC fiber had a lower minimum creep rate than the other two fibers did. meaning that it was slower to degrade under exposure to mechanical stress and elevated temperatures, suggesting that it may remain stable for longer periods. So over here, the opposite of what is given in the text is mentioned. So that's why C is wrong. So the best answer and the correct answer is D. Choice D is the best answer because it most logically completes the text discussion of silicon carbide, SiC fibers and creep or deformation related to ongoing mechanical stress and elevated temperatures. The text states that Bhatt et al. Found that a nitrogen treated SiC fiber had a lower minimum creep rate than two polymer derived SiC fibers did. Because having a lower creep rate means that the material is slower to deform with exposure to stress, as the text explains. This finding suggests that aerospace composites made with the nitrogen treated SiC fiber may be able to withstand mechanical stress for a longer period than those made with the other two polymer derived SiC fibers can. So, the main thing is that being treated with nitrogen means it will last longer from the creep. So A, we have to be aware that it overstates. So don't choose any answers where it's overstating something.